Okay, so this video clip, we're valuing employee stock options using the Hull-White 2004 model. And we don't use this first snippet of code here. We're going to make use of this snippet just below on this portal. Right, so we use this VBA code, which does a couple of things. It respecifies the model with some boil-low insights and for the barrier, which is implicit in Hull and White. And we also make use of dynamic memory with truncation for the barrier and for the zero region. Okay, so I've taken this snippet of code and we've inputted it into the developer, into the Visual Basic editor, and that same snippet of code is there, and we've previously run some estimations that are consistent with the paper that we had on the portal. So the paper is the Hull-White, is this paper here, accounting for employee stock options, accelerating convergence, and we're looking at specifically for the moment table 5, right, where some of the estimations are set out. Okay, if you want to find that paper, the easiest place to get that, to retrieve that paper, is on this link here, right? And you can download the paper from SSRN. Okay, so if we go back into, for a moment, the spreadsheet, we have the values here. The true value is, again, going to the paper, the true value for those parameter inputs, these parameter inputs here, the true value is 2785. But within 1,000 steps we can get 2785.3, which is very close to true, whereas a traditional Hull-White implementation that doesn't possess any boil-low configuration and doesn't use dynamic memory or truncation, that is oscillating a bit wild here. If you look at the going from 500 steps to 1,000 steps up to 5,000 steps, we're far from being close to convergence. We're still at 28 at 5,000 steps, but a standard Hull and White 2004 model, we're still significantly far from true, whereas the Hull-White boil-low model, even at 1,000 steps, 1,500, is getting us close to the 2785. Okay, so a few issues then arise, in particular issues that are related to the Financial Accounting Standards Board. They, in this document, they set out to approach valuation for employee stock options. So they provide an update on some previous guidance that they presented. Now we might just take a quick look at I think it's page 52 or 60. I think that's where we need to look at here. So 62, and in section okay, so we have, okay, let's go back a little bit. I think it's page 52. So we look here at the evaluation techniques. In applying a valuation technique, the assumptions used shall be consistent with fair value measurement. That is, assumptions shall reflect information that is or would be available to form the basis for an amount at which the instrument being valued would be exchanged. In estimating fair value, the assumptions used shall not represent the biases of any particular party. Some of those assumptions will be based on or determined from external data. Some other assumptions, such as the employees' expected exercise behavior, may be derived from the entity's own historical experience with share-based payments. Okay, and then we come down to the lattice. So a lattice model, so this is section 718.10.55.16 from the FASB standards, and they recommend using lattice model with or Black-Scholes or Monte Carlo. But when we examine these models, the parameters that must be included are the exercise price of the option, the expected term. This should take into account both contractual term of the option and the effects of grantees' expected exercise and post-vesting termination behavior. In a closed form model, the expected term is an assumption. So in a Black-Scholes model, the expected term is an assumption. While in a lattice model, that's a binomial model, that's the style of model we use here with Hull and White 2004. While in a lattice model, the expected term is an output of the model. Okay, so once we put in the maturity of the model and the vesting period, then employ stock option because of the barrier or the multiple that's implicit in the Hull and White 2004 model. The expected term is implicit or is an output of the model, right? We need to include the current price, the expected volatility, and dividends. Okay, so why are these particular parameters of interest, and how would they impact in terms of the model estimation? And we can examine some of that in our spreadsheet here using the code that we've already copied into the Visual Basic Editor. So our starting point might be just to note that the dynamic truncated, the Hull-White-Boileau model for 1000 steps with those parameters is equal to 2785, and we have the same result here, 278530. And for 500 steps with Hull-White-Boileau, it's 2786, whereas the results, and this is very close to true, whereas the results from a standard implementation of Hull and White, so this is a Hull and White, whereas below Hull-White-Boileau output, more efficient and faster. Okay, so couple of things we might be curious then, what are the effects? If we go back to the document, there is some of the issues that some of the parameters we need to address are the exercise and also the current price of the underlying share. Okay, so let's take a look at how might that current price of underlying share affect employee stock option using the model, the Hull-White-Boileau model that we have here. So first thing we might do is take the 2785, right, and we set it equal to this cell, and then we'll run a data table. So we'll set out a set of conceivable stock prices, and we'll substitute in for the value here. So we have set out the range of different parameter variable values for S, the current stock price, and we can make this a little bit more efficient if we change because the number of steps as it increases, that increases the computation time taken. Might note if we reduce this to 50, the level of accuracy, the current at 1000 steps, we get 2785.30. With 50 steps, we're at 2786.32. If we go back to the original paper for a moment, we can see that that's actually very close, true, 278551, so 2786 rounding up. And at 50 steps here, we're at 2786. So 50 would appear to yield a reasonable level of accuracy. We might just start our data table then using this lower step size. So we initially would go to the data tab and then what if analysis, data table, and then because it's a column of data we use the column input cell, and then what in the original parameter inputs, the current stock price, do we want to substitute for, and we run, and that just takes a second then to get some output to appear. So might pause for a moment. Okay, so now those parameter values have filled in, so we can take, we want to graph that, just examine the relationship between the various stock prices and the value of the employee stock options. We can go to insert, come to a scatter graph, and then observe what the relationship is. And what we see here is the value of the employee stock option ESO versus the current stock price. Okay, and that time value there looks consistent with conventional time value parabola. Now, if we go back to the parameters that the guidance provided by the Financial Accounting Standards Board provides us with, a number of the key parameters that we must take into account are not just the stock price, but also the volatility, the expected volatility of the price of the underlying share. So from what we observe here, as the stock price increases in value, the employee stock option value also increases. It's a positive relationship, and that's what we might expect.